This is problem 7-129 from section 7.2.2. Find an equation for each graph below. Well, so here's the question. Is it going to be sine or cosine? And we've seen this before when we talked about transformation, that if I can just move the cosine graph over a certain amount, it's going to become the sine graph. So I'm going to assume all of these are going to be sine functions, where that starts at 0, 0, and just it's shifted from there. Okay, so because cosine can be made from sine, we're going to assume these are all sine graphs. Okay, so part A, I wanted to start at 0, 0. So let's first of all look at the height. So from 0, 0 is where I started. I moved it up. Actually, let's go from here is 0, 0. That's the original point. So how far is that up from the ground, or from 0? Well, it moved up 2 spaces. So for part A, we have y equals, here's our general formula. Okay, so what we have is a shift up 2 units, right? A vertical shift up. Well, that's my k. So far, I know that this is going to be worth a 2, plus 2, okay? Because I went up 2 units. So if I shifted that down 2 units, and I need to get that circle, this one right here, to be at 0, 0, I'd have to move it over, okay? This graph is shifted over from 0, 0. It's shifted over this little interval right here, okay? And so each of these little notches on our graph is worth pi over 4 in this particular graph. So it moved to the right pi over 4, okay? So to represent that, I'm going to do y equals a times sine of x. We do the opposites of x minus pi over 4. So that's 4, or pi over 4 to the right, and then it moved up to 2. Now this a is for the amplitude. Okay, so let's look at the distance between the top and the bottom of the curves. So the top is at 3, the bottom is at 1. That's a total distance this way of 2. Normally my sine curve goes from positive 1, let's say negative 1 up here, and then positive 1. So it oscillates between those two. Okay, so that's a total distance of 2 as well. So since this is a total distance of 2, my amplitude is just going to be a 1, or I don't really write it. Okay, so I'm going to erase this part. So here's our equation for part A. Y equals sine of x minus pi over 4, and then plus 2. Okay, so part B, let's look at that graph. Again, I'm going to assume all of these are sine graphs. So let's say that this point right here is supposed to be my 0, 0. So let's look, where is it shifted? How about first vertically? How much of a shift has that gone? Well, that went up half of a unit. So far I have my k value. So my k went up 1/2, or 0.5. Let's say up 0.5. Okay, so I'm assuming that one that I circled, you could assume either of those 2 dots is the starting part of the sine function, but I'm just going to assume the left one. So if you assume the right one, it's going to be a little bit different equation. So here I moved it up 1/2 of a unit, and it's also moved, right, 0, 0 is supposed to be here, right in the middle. It moved to the left pi over 2. So left pi over 2 is going to be where my h is involved. Okay, so now I have y equals a times sine of x. It's the opposite, so left is normally negative, so it's going to be plus pi over 2 plus 0.5. Okay, so now last thing is the amplitude. So we're going to look at the top and bottom height. So this is at 2, this is at negative 1. So that is a total distance of 3 units. Okay, now my normal one is 2 units. So here's how I'm going to think about this. So the old irregular amplitude is a 2. Well, let's say total regular distance is 2 between the things. This is my new distance is 3. So what do you do to 2? What do you multiply 2 by to get to 3? Well, I'm going to multiply it by 1.5. Okay, so this 1.5 is going to be my amplitude. So my new equation for B is going to be y equals 1.5. That changes how high and stretched it goes. Okay, 1.5 sine of x plus pi over 2. plus 0.5. So this is part B's equation. Okay. Part C, graph C. Again, I'm assuming it's a sine. Let's have this guy right here. We're going to assume that's supposed to be 0, 0. Okay. So first of all, look at the vertical shift up. If that's supposed to be on 0, it's really up at 2. So we moved it up 2 units. So we got to do C here. Y equals, I just think it's easier to start with one thing at a time and then fill it in as we go. So it was moved up 2 units. Okay. So now let's look at the horizontal shift. If that's supposed to be 0, 0, it's moved to the left a lot. So in this case, it's a little bit different units. So we got to figure out each of these is worth pi over 6. So that's 1, 2, 3, 4, 5 pi over 6 to the left. Left, 5 pi over 6. Alright, so now we have an h value. So it would be x plus 5 pi over 6. And then I have a plus 2 on the outside. Okay? So that means I moved it to the left 5 pi over 6. Last is my amplitude. Let's check it. How high? What's like the range of my function? It's 3 and to 1. That is a distance of 2. That's normal. Okay? From -1 to +1. This is from 1 to 3. That's still a distance of 2. So my amplitude is just going to be a 1. So let me erase this guy. So that is our equation for part C right there. My amplitude is a 1. Alright, part D. Last graph. I'm going to assume this is my 0, 0. Again, you could assume either of those points is 0, 0. You're just going to get a different equation based on where you start from. So that is it is moved down -1. So my vertical shift, my K, so far I know is it's down 1. Okay, so remember my K value it stays with how it normally is. If it's down, it's going to be negative. Now let's look at my shift left and right. That needs to be 0, 0. So from 0, 0, they moved it to the left pi over, let's see, each of those is worth pi over 6 again. So they moved it 2 pi over 6. No. They moved, each of it is worth, yeah, pi over 6. So this is 2 pi over 6, which I'm going to reduce it to pi over 3. Alright, that's simplified. So it's to the left there. So let's figure this out. We move down here. So this, it was to the left pi over 3 when I simplified it. So now I know y equals a sine of x opposite of that, so plus pi over 3, and then minus that 1 on the end. Okay. So last but not least, we have our amplitude. So let's look at this. And if I use this point right here to be my starting point, look at, normally sine goes up first, right? But this one's going to go down first. So that means it's reflected. So that means it's going to have a negative amplitude. Okay? So let's look at the actual value of the amplitude now. So it starts up at 2, or its highest point is 2, its lowest point is -4. That's a distance of 6. So the way that I told you about it was my regular amplitude, or my regular distance between them is 2. My new distance here is 6. So what do you do to 2? 2 times what? Well, 2 times 3. So 3 is my amplitude, except it's going to be negative because I'm reversing the direction. If you picked the other point, if I go back up here, sorry, I'm probably making you sick watching this problem. If I use this point right here, then my sine would start up. Alright, and start going up. Now, if I did pick this one though. I'm basing my stuff off this one. So I'm going to have a different equation than if you picked the other point. But it's okay. So we know I have a -3 is my amplitude. So y equals -3 because it was reflected. It's flip-flopped from normal. It was moved to the left pi over 3, and it was moved down 1. So this is my final equation for this problem. This is a lot of new stuff happening, but no, I'm basically going to base it off of my sine equation because cosine can become sine. So just whenever I'm making an equation, base it off of how sine looks because that's usually the easier one.